Okay, this question is asking us to find the first and second derivative of this equation. I'm going to write it down real quick. 2t3 minus 18t squared plus 48t plus 67. Okay. For first derivative, we're going to want to do the power rule. It's going to be 2 times 3t 3 minus 1 minus 18 2 t2 minus 1 plus 48 times 1 t1 minus 1 plus 67 0. And this is going to result in 6t3 minus 36t to the 2 plus 48, and then there's going to be no 67. And then we're going to, based on this, we're going to want to find our second derivative, which is going to be 6 times 2, t2 minus 1, minus 36 times 1, t1 minus 1, plus 48, 0. And this would give us 12p minus 36. And that's all we would have to do for this problem. For the next problem, we're going to want to use our first derivative as the velocity equation and find when the particle is at rest. So we're going to want to write down our derivative first. 6t2 minus 36t plus 48, and we're going to set this equal to 0. Now to continue, we're going to want to factor. So we're going to factor out 6. We're going to get t2 minus 6t plus 8, which equals 0. And we're going to want to factor out this right here. We're going to keep the 6 right next to it. This is going to be 6t minus 2, t minus 4 equals 0. And then we're going to solve for these. There's going to be t minus 2, 0 plus 2 plus 2, t equals 2. T minus 4 equals 0, plus 4 plus 4, t equals 4. So our particle is at rest at t equals 2 and t equals 4. Now we need to determine which intervals of s of t are increasing, and to do this we're going to need a number line. Let's draw one out. Now we're also gonna remember that this 6 equals 0. So we're gonna wanna remember this 0. We're gonna put our 0 here. We're gonna wanna put our 2 and 4 right over here. And we're gonna wanna find intervals to test. So s of t, or 1, s of 3, s of 5. So we're gonna do that real quick. We're gonna do 6 times 1, 2 minus 36, 1 plus 48, 6, 3, 2 minus 36, 3 plus 48. And then 6, 5, 2 minus 36, 3 plus 48. We just need to know if they're going to be positive or negative intervals. So it's going to be positive, it's going to be negative, it's going to be positive. This is going to be bigger than this one. This is going to be positive. And this interval over here is going to be positive. And then this is going to be positive. This is going to be negative. This is going to be positive, but this is going to be a lot bigger than both of these. It's going to be negative. And this is going to be positive, negative, positive, but this is going to be bigger than this one. It's going to be positive. So we know our intervals are increasing. So we know that S of t is increasing on 0 to u4 to positive infinity because we have no set spot. Okay. And then for our last question, we determine when the particle is moving west. Now, west is going to be moving towards positive infinity. West is moving towards positive infinity, and east would be moving towards negative infinity. So we know that it's going in the west direction from 2 to 4 because it goes from decreasing to increasing. So the particle is moving west from 2 to 4. It goes from negative to positive, which means it has to be going to positive infinity. For this problem, it's asking us what intervals of time does a particle have a negative acceleration. We're going to want to use our second derivative. So let me write that out real quick. 14 minus 36. And we're going to set this out to 0, plus 36, plus 36. 12t equals 36 divided by 12 divided by 12. T equals 3. And we're going to do a little number line to figure this out. We're going to have our 0 here and our 3 here, and we're going to find intervals. So we're going to want to do f of 2 and then f of 4. 12 times 2 minus 36 is going to be negative because this number is going to be smaller than this number. And then 12 times 4 minus 36 is going to be positive. So the particle has negative acceleration on the interval 0 to 3. And then for our last problem, we want to determine which time intervals the particle is slowing down. So we're going to want to draw two number lines. And we're going to want to use both of the number lines that we use for the negative acceleration and the increasing. So let's put our negative one down here. We're going to have 0, 3, 0, 2, and 4. And we know this was positive, this was negative, this was positive, this was negative, and this was positive. So for sure, the particle is slowing down from 0 to 2 to 3 to 4 because we can see that plus times negative equals negative. This would be slowing down. And then over here, we have negative times positive, which equals negative.